Hello.
Hello, hello. Like we can record the everything, right? First we can show the GitHub. Actually, this is our project. This is Edgeinferinator. Hi guys, this is our project. This is Edgeinferinator. So what exactly is this is? It's like a machine learning predictor for microcontroller. Like for example, you can deploy the model in cloud on any device, right? So this is for deploying the model in the microcontroller, like Arduino and ESP32. This example I'm using ESP32 as a microcontroller. So what our exact goal is, we are going to predict time series values for Home Assistant to offload the processing of Home Assistant. Actually, what Home Assistant is? Home Assistant is a automation device which is like Alexa and Google Assistant and like Apple HomePod. It's similar to that, but it's open source and it's community based, so everyone can contribute to that, and it's so nice. So in Home Assistant, it will control all the IoT devices. It gathers, aggregates all the IoT devices into one platform, which is I hosted a Home Assistant in a virtual machine. I can show you that, just a second. Yeah, here. This is the Home Assistant interface. This aggregates all the IoT components in the project in the home. So what it also do is, we can also collect data from IoT devices and we can do predictions and regressions in the Home Assistant. So this project offloads the inference part into a separate into a into a edge device itself, like the sensor device itself, like in this case ESP32. So why you want to do this project? Because there are multiple reasons. One is the Home Assistant, even though it's like open source and it's like a private one, we don't have to host it on any cloud or something. We can host it in the our own system or on a Raspberry Pi. It can run locally, but even though it's run locally, it's like a centralized system. The IoT devices depend on it. We have to write automations and everything in the Home Assistant panel, so the IoT devices can do their work accordingly. If the network goes down, if the Home Assistant goes down, everything goes down. So mostly what people do is uh, embed some basic functionality into the sensor device itself, like turning on at this if the proximity hits, or turning on if motion hits, motion sensors. So these like basic things they will embed in the they embed the program in the controller itself, so it doesn't want to depend on the Home Assistant to do all those basic stuffs. So what we are extending is, we can also embed the code, like ML code, machine learning inference. We can also embed the inference in the edge itself, so we cannot we don't want to depend on the Home Assistant for inferencing also. So we, if the Home Assistant goes down, it's like a completely decentralized system. If the Home Assistant goes down, nothing goes down. Every individual nodes, like every individual sensors has their own ML model and predicts everything and do their functionalities. So nothing goes wrong. And the another one advantage is, we have we are doing the every inference part in the edge, so it won't take much bandwidth to use that, even though it is like a private network. And also the inference is like happening in the edge. We can do like we can sort out the issue quickly rather than going to the home assistant, predicting it, sending the data back to the ESP32. So this is how it works. And these are some of the tech stacks we used, like Edge Impulse, where we are it's used to collect data, pre-process, train the model, and convert it into TensorFlow Lite model, and eventually into TensorFlow Lite micro model for deploying it in the microcontroller and ESP32 microcontroller. Why I use ESP32 is they provide like dirt cheap controllers, and they have a like a guarantee or something like that. They will like produce this for this much period of time, like 10 years or 20 years or something. So it is easy to manufacture. Like if you want to manufacture a product with that, you can easily depend on them, and it's dirt cheap, and it has a built-in Wi-Fi and Bluetooth, so you can use it to connect to home assistant or any other devices. We are using MQTT protocol to communicate, like to communicate IoT signals from home assistant to microcontroller, microcontroller to home assistant, and we are using MongoDB to back up our data. We are collecting the sensor collect the ESP32 collects data, right? The data will be processed in the device itself and take action, necessary action in the device itself, but it also sends the like what it's detected to the home assistant for viewing purpose, and it also sends the anomaly signals. It also has an anomaly model. It also sends the anomalies predictions to the MongoDB to view it later or for further analysis. We are using MongoDB Atlas, and we are exposing the home assistant, which is private, right? We are exposing it to the like internet through Cloudflare Agro tunnel. We are using the GoDaddy's free domain. We are provided to create a domain register a domain name, and we are using a tunnel through it, so everyone can access home assistant, even view. Now it's called Edgeinferinator.ca cco sorry Edgeinferinator. That's like a hard name. We inspired it from the Dr. Dufan from Phineas and Ferb, and these are all some usage which I already said. So now we are going to see the coding part. So this is like a C code for ESP32. I written some of them in platform IO and some of them in Arduino. Both are C, but it's just like variables like API keys and server name for the MongoDB instance, and for the model parameter I trained the model in Edge Impulse, which I show you soon. These are some of the test samples we are going to predict. Since I am not connecting to any mm, sensors, we are using this data to predict the values. So this is like a test sample we are having, which is embedded into the code. But in the if you're doing like in a full-fledged project or product, it will be like it will be coming from the sensor, external sensor. Since we are not attaching any sensor right now, we don't have, so we are using some test data to predict the things. And these are classes for home assistant, and it's now predicting, like right now we can see the predictions and anomaly scores and everything. It has 5 classes like circle, forego, rotate, waving. These are classes collected from accelerometer data. So it's like a gesture thing. So it's predicting those values, and it's also giving the anomaly value. We can not only use accelerometer, we can use any sensor data we want, like any time series data. This code right now I'm using supports all type of time series data. You can use temperature data, moisture data, everything. It's up to your imagination. So these are like the predicting output, and these are sent to the home assistant in real time. You can see that here. these changes. Like when it finds circle is opened, circle is triggered, it's triggered. And when if it finds a circle, the class circle is triggered again, it will get closed. You can see the logs, and you can also see the MongoDB Atlas, which I show you soon. You can see the code, like anomaly score coming, logging as a time series data in MongoDB. Okay, I think that's what the project is about. We have many future scope to do. We have to reduce the model even more to get better performance. Now you can see that the it's performing it the digital signal processing using 19 milliseconds, and inference is, I think it's showing 0, but it will be less than 5 millisecond. It's like a small model. uh, I'm going to show you the edge impulse part, like, just a second. This is the edge impulse which I talked about for training the model. This is some collector data. It is already there, collected predefinitely. We didn't collect the data, we used the data to train the model. This is our impulse, which is we are using. This is the data labels contained in the data set. We are using just the x-axis values. We are just a second. We are using a neural network, which is Keras neural network, and we are also using a k-means anomaly detection for detecting anomalies. Sorry, for this model we are using six variables, and these are the classes, like as I said before. And this is spectral features, like we have to do the basic pre-processing steps like FFT, filtering, everything. It's like a low code thing. We started with the entire coding thing, but due to the time constraint we came out to examples to make it easier. So this is the neural network, which I which is just it has just 3 dense layers and one dropout layer and then final layer, softmath layer. Even I don't know much about this, I just visually edited. Like we can go to visual mode and we can choose the number of layers we want. We can adjust the architecture based on the results. And it's anomaly detection model. We have to find how many cluster count we want. We have to test it like different parameter to find suitable output. And at the end we can, if we need, we can export it as Arduino library or C++ library. And it is a context model. It's an int8 context model. So uh, that's what I'm importing it here. This is the output of the build, which came as a dot header file. It will come as a header file. So we are using that, and we are using Home Assistant, and we are using MongoDB. We are using these 3 things to do this project. And thank you. And I have MongoDB in another system, which I will show you now. Where is OBS?